Ever wondered how FP growth algorithm works in data mining? Well, it's a fascinating concept that plays a key role in the world of data mining. The FP growth algorithm, or frequent pattern growth algorithm, is a method specially designed for frequent item set mining. This is a critical aspect of many data mining tasks, from market basket analysis to social network analysis. What sets the FP growth algorithm apart is its unique divide and conquer approach. Unlike other methods that use candidate generation, this algorithm creates a compressed version of the database, known as an FP tree, and then partitions it into a set of conditional databases. This process allows the algorithm to efficiently discover frequent item sets, outperforming other methods in terms of speed and scalability. Exciting, isn't it? So let's dive deeper into how the FP growth algorithm works. Stay tuned as we unpack the concept of the FP tree and walk you through the steps of the FP growth algorithm. At the heart of the FP growth algorithm is the FP tree. This isn't your typical backyard tree. Instead, it's a compact data structure that stores a treasure trove of information. Imagine a library that, rather than books, holds an item set database. But this isn't just a storage facility. The FP tree is designed to preserve the association information of these item sets. Picture this. We start with an empty root, a blank canvas if you will. Then we add transactions, but we don't just dump them in. Oh no, we add them one by one, carefully, thoughtfully. Each transaction is a new branch on our tree, a new piece of the puzzle. And as our tree grows, so does our understanding of the interplay among the item sets. It's like watching a story unfold, a story told in data. Now that we understand the FP tree, we can move on to the actual steps of the FP growth algorithm. So, how does the FP growth algorithm work? Let's take a deep dive into the mechanics of the algorithm. It's a two-step process. First off, we have the construction of the FP tree, something we touched on in the previous scene. This step involves scanning the database to find frequent items and ordering them based on their frequency. Afterward, we create the FP tree, which is essentially a compressed representation of the database, using these frequent items. Now, one might wonder, why go through all this hassle? Why not just use the original database? Well, the answer lies in efficiency. The FP tree provides a more compact and efficient way to store and navigate through the massive amount of data. It's like having a map when you're exploring a new city. It simplifies the process, doesn't it? Once we have our FP tree ready, it's time for the second step, the extraction of frequent item sets. And this is where the real magic happens. The algorithm uses a depth-first search strategy to traverse the FP tree. It starts at the root and goes as deep as it can down a path before backtracking. This approach helps to find all the item sets without missing any. But that's not all. The extraction process also uses a clever technique called pattern fragment growth to generate the frequent item sets. It combines the item sets found in the path with those found during the backtracking process. This way, it doesn't have to generate and test every single combination, which can be a very time-consuming process. It's like finding the most popular dishes in a city without having to try every single one of them. This depth-first search strategy and pattern fragment growth technique are key to the FP growth algorithm. They significantly reduce the search cost, making the algorithm much faster and more efficient than its counterparts. That's a lot to take in, isn't it? But don't worry. With practice, these steps will become second nature. Let's recap the key points we've covered about the FP growth algorithm. This is a crucial tool in the world of data mining, enabling us to find frequent patterns in large datasets swiftly and effectively. The cornerstone of this method is the FP tree, a compact structure that encapsulates all the essential information about frequent patterns in our dataset. Unlike other techniques, FP growth algorithm saves us from the laborious process of generating candidate sets, making it a more scalable and efficient solution. The algorithm essentially involves two main steps. First, the construction of the FP tree, which entails scanning the database twice and arranging items in order of their frequency. Second, the extraction of frequent item sets from the FP tree, a task achieved through a recursive divide and conquer approach. And that wraps up our explanation of the FP growth algorithm. Remember, understanding is the first step towards mastery. Keep practicing,